Hi everyone, welcome. In this video, I am going to show you how to reverse a number in Java. First of all, let's understand what reversing a number is. Let's take an example of a 4-digit number. Let's say for example, I have a number called 1729 and I wanted to reverse this number. Reversing a number is, we usually read a number from left to right, and reversing a number is reading the number from right to left, meaning 9, 2, 7 and 1 in this case. This is what reversing a number is. And how to achieve this? So if you observe this number, what we are doing when we are doing manually, we are actually looking at the rightmost digit, picked up that digit and added it some place, and then we picked up the next rightmost digit and added to the existing number where we placed 9, and then we pick up the next rightmost digit. That's how we can achieve reversing a number. Let me put it here. What we can do, we can extract the rightmost digit and add the rightmost digit to some place, and then how to achieve the next rightmost digit. For that, what we'll do is, we already achieved in this case 1729, we achieved extracted 9 and added it at some place 9. Now I wanted to get the next rightmost digit 2. How do I get it? So for that, what we can do is, I can actually remove this rightmost digit, and then what I'll be having 172. In this, what is the rightmost digit? 2 is the rightmost digit. So in the third step, like what we are going to do is, we are going to remove the rightmost digit. You can see here, I'll just write removing the rightmost digit. We'll remove it, then whatever the number we are left it with it, we'll go back to the first step and we'll extract the rightmost digit. What is the rightmost digit now? 2. So 9, we'll add it 2 here, then remove the rightmost digit. Rightmost digit is 2. Then again what we'll do, we'll remove 2. What happens? We are left with only 17 now. Again we'll go back to the first step, extract the rightmost digit. Rightmost digit now is 7. So we'll add, the second step is add. So we'll add 7 here and then remove the rightmost digit. Rightmost digit now is 7. So again we'll remove 7. Like that we are going to follow until all the digits in the number is completed, so that finally we will achieve what we wanted, the target number of the reversing a number of a given number. That is what we are going to achieve finally following this procedure. But this is what we will be doing, but how to write a logic for this, let's do that now. So for that, what we'll be doing is, uh, say for example, I have a number. This is our number, right? So how to write a logic to extract the rightmost digit from this number? So any number in mathematics, if you divide it by 10, then whatever the remainder you get will be the rightmost digit of that number. Any number you can take. Say for example, you take a random number like 512 or anything, 512, then divide that by 10. Then you might get some divisor as 51, but the remainder will be 2. So if you observe there, the rightmost digit will be the remainder. So even in this case also 1729. If I divide this number by 10, I might get some divisor, but the remainder what I get is 9 definitely. So that is what I wanted. If you observe, the first step is extracting the rightmost digit. And how to extract it, how to write the logic for that, we'll divide the number by 10 and get the remainder. Remainder is 9. Now as a second step, what I will do is adding the rightmost digit. So let me put it as add it for now. I added the remainder, rightmost digit we extracted. How we extracted? We divided the number by 10 and got the remainder. We added at some place. Let's say for example that place is, let me put it here. I added it. I have 9 here. Now the third step. The third step is we wanted to remove the rightmost digit. How to remove the rightmost digit? Again, in math we have something called when we divide the number by 10, then whatever divisor you get will actually remove the rightmost digit and will give you the remaining number. In this case, when I divide 1729 by 10, the divisor I get is 172, leaving the rightmost digit. This is what we wanted. Anyway, we wanted to remove the rightmost digit. We wanted to remove the rightmost digit and achieve the and get the remaining number. This is what we wanted. So for that, what we are going to do is we'll again take this. We'll divide the number by 10 and get the divisor this time, so that the divisor will be the number leaving the rightmost digit in that number. So this is what we wanted to achieve. And if you observe, now we have 172 here. We'll go back to the first step again. Divide the number by 10 and get the remainder. So 172 divided by 10. What will be the remainder? Divisor will be some 17, but what will be the remainder? 2 will be the remainder. Now observe, add it. How to add it to the existing number? We already have 9 here, and I wanted to add 2 beside 9. If it is not directly adding 2 here, I can't add 2 directly here as it is not a string. So if I had some string say Java, and I wanted to add characters in it by reversing it, maybe I can take a v, I can concatenate it directly, but it is not like that here. So if you observe, uh, numbers are, you can't directly concatenate the numbers. But how to achieve that? This is the number, I have it, and I wanted to achieve this number, placing 2 beside 9, meaning uh, position changes. The existing number position changes uh, by 1. It actually moves left position, one position left to the existing position. So if you observe, 9 is becoming 92 now, meaning what happened? It actually increased its value by 10 times. First of all, it increased its value by 10 times. Then what happened? Whatever number you wanted to add it, then you can add it. Now what happens? You can see here. First of all, you had 9 and you wanted to achieve 92. How do you do that? And you can clearly observe the value here. 9 becoming 92. First of all, it has to increase its value by 10 and then add the value whichever you wanted to add it. Then it becomes 92. This is the logic we are going to follow in this second step. Now, divide the number by 10 and get the divisor. What is the number? 172 is the existing number. When I divide this number by 10, what the divisor I get? 172 divided by 10, I get 17. 17 as my divisor. So we have only 17 now as the number. We already added 2. So 17. Again go back to the step 1. You divide the number by 10 and get the remainder. So this time 17 divided by 10. What is the remainder? 7. Now add it. How to add it? We already have the logic here. We have the existing number as 92. We placed it somewhere here, and 92 into 10 is 920, plus this time remainder is 7. So 920 plus 7, 927. So my value now became 927. Now third step, divide the existing number by 10 and get the divisor. 17 divided by 10. What is the divisor? So 10 ones are 10. 7 is the remainder and 1 is the divisor. So I have 1 now. My existing number is only 1 now. Now again go back, divide by number by 10 and get the remainder. 1 divided by 10, I will have only 1 as the divisor will be 0. Add it. How do you add it? Again you do 10 times of the existing number. So 9270 plus 1. So it will be 1 now. 9271. And divide the number by 10 and get the divisor. 1 divided by 10 anyway will be 0. So then we'll stop it here. And if you observe, once all the digits are completed, we'll stop there. And if you observe, we already achieved what we wanted. This is what we wanted. If you observe here, this is our target number. We achieved it. This is what we are going to apply. This is the logic we are going to apply when we are writing the program. Now let's create a class, Java class. Let me name my class as reverse number, take the main method and just say finish. You can remove this. And for now, what I'll do is I'll just say it as original number, and I'll hard code it for now. And I also wanted to store the reverse number, so I'll assign it as 0 first of all, and then let's write a while loop. Looping is for how many iterations we wanted to loop. This I'm not sure like how many times I wanted to loop, as the number can be of any digits, so I don't know how many iterations I'll be looping. So for now what I can do is I don't know the condition, so I'll come back to this condition later. And let me start writing the logic here. So you can see here, let me remove this. So okay, what I can do is I can remove this. Yeah, now it will be clear. We'll apply this same logic here. So first of all, what we wanted to do, we wanted to divide the number by 10. So the original number we wanted to divide it by 10 and get the remainder. So the remainder I will be storing into some new variable like this. I'll name it as rem, and original number I wanted to divide it by 10. I'll just do divide by 10. Now I have the remainder. I wanted to add it. How do I add it? So you can see here, reverse number. How to achieve it? First of all, you increase the value by 10, multiply the value by 10 times, and then add the remainder to it. This is what we did here. The same I'm writing it as a logic. So you can see here. Then the third step is dividing the number by 10 and get the divisor. Now here, sorry, it is remainder. So we should be using percentile. In Java, if you use percentile, you will get the, when you divide this number by 10, whatever may be the remainder, you will get it, that number, the remainder, and will be stored in this variable. So using this modulus or remainder symbol, you will get the remainder of that number. No, I wanted to get the divisor. How do I get the divisor of the number? Original number equal to my original number. I'll just divide it by 10. Then whatever may be the divisor, I'll get that and stored it in this original number. Actually, you can put it into some new variable. You can declare it into some variable, and you can store the value into that variable as well. But here, I don't anyway need this original number, so I'm modifying the existing number itself. Now we achieved these three steps. We wrote the logic, we completed the logic. So, but we are not sure how many times this has to iterate. This condition we are not sure. Now let's actually talk about that. Let's find out that condition. What can be the condition? For that, let me take a table here and let's start. So at the beginning, my original value is 1729. Let me write it here. Let me change the color. And reverse number is 0. Let's write it as 0 here. And you can see uh, it is remainder. This is remainder. We'll store it remainder here. And the remainder, we don't know it. In the first iteration, even before entering into the while loop, we don't know the remainder, as remainder is declared within the while loop. Now let's go into the while loop. Let's say, for example, this while condition is true for now. We'll get back to this condition later. Let's say, for example, it is true for the first time. It enters. Now we are going to calculate remainder. Original number is 1729. Percentile 10 is when it is divided by 10. What is the remainder I get? 9. So in this iteration, I should be writing 9 here. I'll be getting remainder as 9. So let me write 9 here, and then reverse number. What is the reverse number? Existing number. So we wanted to add this number, right? So first of all, we initialize the value to 0. 0 into 10, 0 plus 9. So reverse number is 9. Now version number is equal to version number divided by 10. So we'll get the divisor here. 1729 divided by 10. What is the divisor we are going to get? 172. Now we'll go back to the condition again. Let's say for example this time also condition is true. Now again I will calculate the remainder of the version number. Version number is 1729, 172 now. Percentile 10 is 2. I get the remainder as 2. Remainder is 2 and reverse number into 10. The second step. What is the reverse number? It is 9. 9 into 10 is 90 plus remainder is 2. It is 92 now. And what are we going with the do with the version number? We are going to get the divisor divided by 10. Divided 172 divided by 10. The divisor is 17. Now I'll go back to the condition again. Let's say for example this time also the condition is true. Original number is 17. 17 divided by 10, the remainder is 7. So remainder is 7. Now the reverse number into 10. Reverse number is 92 into 10 is 920 plus remainder is 7. Now this number becomes 927. And third step, original number divided by 10. 17 divided by 10, what is the divisor? You will get it as 1. Write it 1 here. Again go back to the condition. Let's say for example this time also condition is true and version number divided by 10. What's the remainder you get here? 1 divided by 10, the remainder is 1. Write 1 here. And reversing a reverse number into 10. 927 into 10 is 9270 plus remainder is 1. So this time number becomes 9271 and version number is 1 divided by 10, divisor is 0. You can write 0. Now if you observe, I already got the number which I wanted to achieve. 9271 is what the reverse of 1729 and I already achieved this if you observe. So I don't need to loop it back again. So now if you observe, we already achieved what we wanted and you can see the condition here. What could be the condition? How many iterations we wanted to loop this. So we can understand by this example. You can see here when my version number becomes 0. Not only for this example, you can take any number. When you follow this process, what are we doing here? Every time in each iteration, we are actually removing one digit from this number. If you do that like that, so at the end you will have only one digit in any number. In any number, the number can be of any digit. At last you will be left with one digit, and when you divide that one digit number with 10, you will always get the divisor as 0. So what can be the condition now? We can write the condition now. What is our condition? My versional number, when it is not 0. Till that time I should be looping uh, this logic. I should be running this logic until it is not equal to 0, or you can specify greater than 0. Anything you can specify, both are same. You can write anything, and now we are done with finding the condition as well. Now what we'll do is finally we got the reverse number. Let's print that number. I can just say the reverse of the given number is, we finally have stored that number into reverse number. So I'm printing reverse number here. And if you want, you can actually print the original number as well at starting. Original number is this one. Now let's execute this program and check. Run as Java application. And you can clearly see here, version number is 1729 and the reverse of the given number is 9271. So perfectly worked, right? Now what we'll do is we hard coded the value, right? So let's make it generic. For that, let me use the scanner class to read the input dynamically from the console. System.in. So this actually reads the input dynamically from the console. Just import it from Java util, and this one we are going to read it from the console. We'll make this like this, and yeah, you can leave it. And if you want, you can write a small message just to enter a number. Please enter a number like this, and this will read the input from the console and will store it into this version number. We made it generic now. Now let's execute it and check. This time we need to enter a number. So let me write something like this, and you can see the version number is 456 and the reverse of this number is 654. Like this, you can actually verify for any number of for any number. So let's say, for example, I wanted to give some palindrome number. You can see here the reverse of it is also same. And say, for example, I wanted to execute it for some zero if my number has some zeros. So say, for example, like this. In this case, it is 5000. So it should be 0005. But any number of zeros prefixing before any number, so it has no value. So it is printing 5, which is also right. So like this, you can verify for any other numbers as well using the same logic. And this is how you can write the logic and write the complete program in Java to reverse a number. That's it for this video. Thanks for watching.